Hey guys, so first of all, I'm outside, so I hope that the wind doesn't make this video hard to hear at all, but it's just so beautiful out today. It's Thursday, so I had to do it. So we are going to talk today about the square root method for solving quadratic functions or quadratic equations, and you guys have already learned a lot about factoring. So factoring is one of the ways that we can solve a quadratic, just like we looked at last class. Where you can factor it, then you set each factor equal to 0, and you find your zeros. You find what number would make each of those factors, the pieces in parentheses, equal to 0. So today we're going to learn another method. It works in two specific situations. So sometimes these questions you could still factor, but a lot of times these are things that you wouldn't be able to factor. So it's helpful when we see something like that. And I am, just a heads up, going to make an extension video. If you feel like you can push yourself a little bit, I'm going to make an extension video about simplifying the quadratics. But for this video, we're just going to keep it super basic, okay? So when I say it only works for two situations, I am talking about situations where we can easily isolate the variable, okay? So in our traditional quadratic function, we might have ax squared plus bx plus c, right? That's what we're used to seeing. If we do something like this, we sort of have to factor it to get the x's alone, because when you have an x squared and an x, I'm not just going to be able to solve this and get x equals, right? That's going to cause too many problems. So we can only do it when b is equal to 0, and that's what I've written up here first. So you have ax squared, so there can be a number in front of the x squared, and there can be a constant, but there can't be any term with an x in it, okay? Only the x squared showing. So that's one way that we can solve with square root method. The other is if it's in transformation form, and I should have had an a out here. So if you see parentheses and then the squared is outside of that, the power of 2 is outside of that, we can also use the square root method here because we can isolate x, and so I'll show you how to do that in a little bit. So I'm just going to work through a few examples. Some of them are quick, some of them might take a minute, but you'll also want your calculator for this portion as well. So example 1, the equation that I'm giving you is x squared minus 4 is equal to 0. And for all of these, our goal is to isolate the variable. So just like you would solve any other equation, if I gave you 3x plus 1 equals 5, right? You're going to take away 1, divide by 3, and so your answer is 4/3. We're going to do a similar process here, but we have just a power of 2 now. So let me get rid of this real quick. So when I start to solve this, if I want to isolate the variable, the first thing I'm going to do is add 4 to both sides. So x squared is equal to 4. Now I want just x, I don't want x squared, so I am going to, the way I get rid of a square root is, is by taking the square root. And so I get x is equal to, well, if you think about what's the square root of 4, it is 2, right? But remember, with x squared really tells us we should be getting 2 answers here, right? So I know that 2 squared is equal to 4, so that's why one of the x's was 2. But remember, whenever you square something, it always turns it positive. So I could alternately have negative 2 squared with negative 2 as my x, and that also gives me 4. So anytime you're actively taking the square root, not only do you get the positive answer, you also get the negative answer. So it's going to be plus or minus 2, which means we have both positive 2 and negative 2 as our answer. If I were graphing it, it's going to cross at positive 2, it's going to cross at negative 2, and face up. Oops, pretend it goes through that. Okay, so let's look at one. 4 was a perfect square. Let's look at something that doesn't have a perfect square. So x squared minus 5 is equal to 0. Again, we're going to isolate the variable. So I'm going to move the 5 away from the x squared. And now I have x squared is equal to 5. Take the square root. And so x is equal to, well, let's think about this for a second. 5 isn't a perfect square. We don't really have a whole number that will be our answer to the square root of 5. So if we want to leave our answer exact, and sometimes your directions will specify that, we're just going to leave it as the square root of 5. And still, because we're taking the square root, we get both the positive square root of 5 and the negative square root of 5. Okay? If we're estimating where it would be on a graph, that's where that squiggly equal sign symbol comes in. That means approximately, plus or minus, and then in our calculator, which lives somewhere over the rainbow. Okay, there we go. Here we're going to actually find the square root of 5, which is 2.236. Okay, or we can say 2.24. Which makes sense. If the square root of 4 is 2, the square root of 5 should be a little bit more than that, right? So these are approximate answers, and exact is plus or minus the square root of 5. If we're graphing it, approximate is much more user-friendly. But if you're looking for an exact solution without using a graph, then the square root value is better. Okay. All right, let's talk about what happens if I had x squared plus 4 instead of x squared minus 4. Still going to isolate that variable. So I get x squared is equal to negative 4. Take the square root. And now we're thinking, okay, what's the square root of negative 4? Well, there's no good number, no two numbers that are exactly the same that would multiply to give us negative 4. Right? 2 times 2 gives me 4. That's positive. 2 times negative 2 gives me negative 4. But these two numbers are not the same, right? Those are different numbers. And by definition of square root, it has to be the exact same value. If you go back to your calculator, we have, oh no, a commercial apparently, 4. We have negative 4. If I take the square root, my calculator says error. That's because 1 doesn't exist, okay? A real number answer does not exist to this. This is what gives you what we call imaginary answers, and so this is the type of graph you would get where it doesn't actually cross the x-axis, okay? If you watch the extension video, I will show you how to actually simplify this a little bit more with imaginary numbers, but for right now we can just say there are no real solutions. Okay, there's no real number I can put in for x that when I square it and add 4 is going to give me 0. Nothing will do that. All right. Okay, so the next one, 3x squared minus 8 is equal to 0. Again, let's go ahead and isolate the variable. So I'm adding 8 to both sides. I'm going to divide by 3. Get rid of that a term. So x squared is equal to 8 thirds. And then I will take the square root. So x is equal to, again, both positive and negative. And when you take the square root of a fraction, you can split it up over numerator and denominator, or you could leave it as 8 thirds, right? Either way, that works perfectly fine. Again, if you watch the extension video, I'll show you how to simplify that a little bit more, okay? And then, lastly, what if it's in transformation form? Ax minus h squared plus k. This time the k is already on the other side. And I'm actually going to give us a value here. Let's make that a 4. Just so we have a little bit more to work with. So let's work on isolating the variable. In this case, that means isolate the parentheses, because the variable is inside of the parentheses, and I'm going to have to get rid of those before I can solve for it. So, firstly, what I want to do is the constant is already on the right hand side, so I'm going to leave that there. And I'm going to divide by 4 because I want to get rid of the number in front of the parentheses. I do not want to distribute it in, fight that urge, because the power of 2 is more powerful than multiplication. Remember, you do exponents before you multiply. So if we do distribute, we're going to do the whole problem wrong, okay? And that's really, 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 really important for you to remember. When I do this, I'm left with x minus 2 squared is equal to 10 over 4, which is 5 over 2, or you could write it as 2.5. I don't care, okay? Then we want to take, because the next thing we're trying to do is get rid of the parentheses, we want to take and get rid of the power of 2. So I'm going to take the square root of both parts, and the square root and the square cancel each other out. So we get x minus 2, oops, that's an x, pretend, is equal to plus or minus the square root of 5 over 2. Again, you can put this right in your calculator if you want it to be a decimal, but let's keep it exact for a minute. And then if I want to get x by itself, the last step is to add 2. Now, a square root and an integer are not like terms, so we have to leave those separately. So my answer would be 2 plus or minus the square root of 5 over 2, or you could do plus or minus the square root of 5 over 2 plus 2. Both of those answers are perfectly fine. That's an exact answer. Oh, I did one right there. I'm just skipping over examples. It's fine. So if I wanted an approximate answer, we could put 5 over 2 into the calculator and figure out what that actually comes out to be as a square root. So let's see. 5 divided by 2 is 2.5, and I'm going to take the square root of that. I get we'll say 1.6, okay? So what we really have here is x is equal to 2 plus or minus 1.6, all right? And so 2 things we can do to get those answers. We can do 2 plus 1.6, and then we can do 2 minus 1.6. That's what that plus and minus is really doing there, okay? So 2 plus 1.6 would be 3.6. 2 minus 1.6 would be positive 0.4. So these would be the 2 approximate places where our graph would cross the x-axis, okay? So again, stay tuned if you want a little bit of a challenge, a little bit of pushing yourself with simplifying these radicals here, and I'll show you how to do that in just a second.